Directories allow users or applications to find resources that have the characteristics needed for a particular task. For example, a directory of users can be used to look up a person's email address or fax number. A directory could be searched to find the nearby PostScript color printer, or a directory of application servers could be reached to find a server that can access customer billing information. The terms white pages and yellow pages are sometimes used to describe how a directory is used. If the name of an object, person, printer is known, its characteristics, phone number, page per minute can be retrieved. This is similar to looking up a name in the white pages of a telephone directory. If the name of a particular individual object is not known, the directory can be searched for a list of objects that meet a certain requirement. This is like looking up a listing of hairdressers in the yellow pages of a telephone directory. However, directories stored on a computer are much more flexible than the yellow pages of a telephone directory, because they can usually be searched by specific criteria, not just by a predefined set of categories. 1.1.1 Directory versus database. A directory is often described as a database, but it is a specialized database that has characteristics that set it apart from general-purpose relational databases. One special characteristic of directories is that they are accessed, read, or searched much more often than they are updated, written. Hundreds of people might look up an individual's phone number, or thousands of print clients might look up the characteristics of a particular printer. But the phone number or printer characteristic rarely change, because directories must be able to support high volumes of read requests. They are typically optimized for read access. Write access might be limited to system administrators or to the owner of each piece of information. A general-purpose relational database, on the other hand, needs to support applications, such as airline reservations and banking applications, with relatively high update volumes. Because directories are meant to store relatively static information and are optimized for that purpose, they are not appropriate for storing information that changes rapidly. For example, the numbers of jobs currently in a print queue probably should not be stored in the directory entry for a printer, because that information would have to be updated frequently to be accurate. Instead, the directory entry for the printer can contain the network address of a print server. The print server can be queried to get the current queue length if desired. The information in the directory, the print server address, is static, whereas the number of jobs in the print queue is dynamic. Another difference between directories and general-purpose relational databases is that most directory implementations still do not support transactions. However, transactions are supported in LDAP and are limited to transactions within the LDAP directory and do not include other transactions. For example, database operations. Transactions are all or nothing operations that must be completed in total or not at all. For example, when transferring money from one bank account to another, the money must be debited from one account and credited to the other account in a single transaction. If only half of this transaction completes or someone accesses the accounts while the money is in transit, the accounts will not balance. General-purpose relational databases usually support such transactions, which complicates their implementation. Because general-purpose relational databases must support arbitrary applications such as banking and inventory control, they allow arbitrary collections of data to be stored. Directories may be limited in the type of data they allow to be stored, although the architecture does not impose such a limitation. For example, a directory specialized for customer contact information might be limited to storing only personal information such as names, addresses, and phone numbers. If a directory is extensible, it can be configured to store a variety of types of information, making it more useful to a variety of programs. Another important difference between a directory and a general-purpose relational database is in the way information can be accessed. Most databases support a standardized, very powerful access method called structured query language, SQL. SQL allows complex update and query functions at the cost of program size and application complexity. Directories such as LDAP directory, on the other hand, use a simplified and optimized access protocol that can be used in slim and relatively simple applications. Because directories are not intended to provide as many functions as general-purpose relational databases, they can be optimized to economically provide more applications with rapid access to directory data in large distributed environments. If your intended use of the directory is to be read, mostly in non-transactional environment, both the directory client and directory server can be simplified and optimized. A request is typically performed by the directory client, and the process that looks up information in the directory is called the directory server. In general, servers provide a specific service to clients. Sometimes the server might become the client of other servers in order to gather the information necessary to process a request. A directory service is only one type of service that might be able in the client-server environment. Other common examples of services are file services, mail services, print services, web-page services, and so on. The client and server processes may or may not be on the same machine. A server is capable of serving many clients. Some servers can process client requests in parallel, other servers queue incoming client requests for serial processing if they are currently busy processing another client's request. An API defines the programming interface of a particular programming language used to access the service. The format and contents of the messages exchanged between client and server must adhere to an agreed upon protocol. 1.1.2 LDAP protocol or directory. The lightweight directory access protocol LDAP defines the message protocol used by directory clients and directory servers. The LDAP protocol uses different messages. For example, a bind request may be sent from the client to the LDAP server at the beginning of a connection. A search request is used to search for a specific entry in the directory. There are also associated APIs for the C language and ways to access LDAP from within Java application. Additionally, within the Microsoft development environment, you can access LDAP directories through its Active Directory Server Service Interface, ADSI. In general, with LDAP, the client is not dependent upon a particular implementation of the server, and the server can implement the directory however it chooses. LDAP is an open industry standard that defines a standard method for accessing and updating information in the directory. LDAP has achieved wide acceptance as the directory access method of the Internet and is therefore also becoming strategic with corporate intranets. It is being supported by a growing number of software vendors and is being incorporated into a growing number of applications. LDAP defines a communication protocol, that is, it defines the transport and format of messages used by a client to access data in an X.500-like directory. LDAP does not define the directory service itself. When people talk about the LDAP directory, that is the information that is stored and can be retrieved by the LDAP protocol. All modern LDAP version directory servers are based on LDAP version 3. You can use a version 2 client with a version 3 server. However, you cannot use a version 3 client with a version 2 server, unless you bind as a version 2 client and use only version 2 APIs. All lightweight directory access protocols, all LDAP servers share many basic characteristics since they are based on the industry standard requests for comments. RFCs, however, due to implementation differences, they are not all completely compatible with each other when there is not a standard defined. 1.1.3 Directory clients and servers. Directories are usually accessed using the client-server model of communication. An application that wants to read or write information in a directory does not access the directory directly. Instead, it calls a function or application. Programming interface. API that causes a message to be sent to another process. This second process accesses the information in the directory on behalf of the requesting application via TCP/IP. The default TCP/IP ports are 636 for secure communication and 389 for unencrypted communications. The results of the read and write action are then returned to the requesting application, as shown in figure 4-1 on page 84. The request is performed by the directory client, and the process that maintains and looks up information in the directory is called the directory server. In general, servers provide a specific service to clients. Sometimes the server might become the client of other servers in order to gather the information necessary to process the client request. The client and server processes may or may not be on the same machine. A server is capable of serving many clients. Some servers can process client requests in parallel. Other servers queue incoming client requests for serial processing if they are currently busy processing another client's request. An API defines the programming interface that the particular programming language uses to access the service. The format and contents of the messages exchanged between client and server must adhere to an agreed upon protocol. LDAP defines the message protocol used by directory clients and directory servers. There are also associated LDAP APIs for C and Java languages, and ways to access the directory from a Java application using Java naming and directory interface, GNDI. The client is not dependent on a particular implementation of the server, and the client and the server can implement the directory however it chooses. 1.1.4 Distributed directories. The term local, global, centralized, and distributed are often used to describe a directory. These terms mean different things in different contexts. In this section we explain how these terms apply to directories. In general, local means nearby. Global means that something is spread out across the universe of interest. The universe of interest might be a company, a country, or the earth. Local and global are two ends of a continuum. That is, sometimes something may be more or less global or local than something else. Centralized means that something is in one place, and distributed means that something is in more than one place. As with local and global, something can be distributed to a greater or lesser extent. The information stored in the directory can be simultaneously local and global in scope. For example, a directory that stores local information might consist of the names and email addresses and so on of members of a department or work group. A directory that stores global information might store information for an entire company. Here, the universe of the interest is the company. The clients that access information in the directory can be local or remote. Local clients may be all located in the same building or on the same land. Remote clients might be distributed across the continent or planet. The directory itself can be centralized or distributed. If a directory is centralized, there may be one directory server at one location or a directory server that hosts data from distributed systems. If the directory is distributed, there are multiple servers, usually geographically dispersed, that provide access to the directory. When a directory is distributed, the information stored in the directory can be partitioned or replicated. When information is partitioned, each directory server stores a unique and non-overlapping subset of the information. That is, each directory entry is stored by one and only one server. One of the techniques to partition the directory is to use LDAP referrals. LDAP referrals enable users to refer LDAP requests to a different server. When information is replicated, the same directory entry is stored by more than one server. In a distributed directory, some information may be partitioned, while some may be replicated. The three dimensions of a directory, scope of information, location of clients, and distribution of servers are independent of each other. For example, clients scattered across the globe can access a directory containing only information about a single department, and that directory can be replicated at many directory servers. All clients in a single location can access a directory containing information about everybody in the world that is stored by a single directory server. The scope of information to be stored in a directory is often given as an application requirement. The distribution of directory servers and the way in which data is partitioned or replicated often can be controlled to affect the performance and availability of the root of the directory. 1.2 Advantages of using a directory is next, inshallah. We're going to quit this now.